The purpose of this video is to demonstrate how to calculate a base flood elevation, or a BFE, using the FEMA-issued Flood Insurance Study Report, or FIS. This training is split into two separate sections. The first section is a presentation that covers the important reasons for needing a BFE and the sources of BFE information. The second section is a demonstration on how to calculate a BFE using the FIS and the Kansas Current Effective Floodplain Viewer. The main points that you will learn are the sources of BFE values and how to calculate a BFE using the flood profile. There are several reasons for needing a BFE. The first is that NFIP regulations require that any new construction or development in the Special Flood Hazard Area, or SFHA, must be built to or above the BFE. In Kansas, there's an additional 1-foot freeboard requirement for development in the SFHA. The second is applying for a letter of map amendment, or LOMA, to remove the structure or land from the SFHA and to also remove the mandatory flood insurance requirement. The third is providing a BFE value for an existing structure's elevation certificate. The official source of FEMA's flood risk information is the Flood Map Service Center, or MSC. And here you can search for a community's flood insurance rate map or firm, a digital version of the firm, which is called a DFirm, and the FIS. You could also access FEMA's National Flood Hazard Layer, or NFHL, which is a geospatial database of all the current effective DFirms. There are a couple of ways to search for a community's flood risk information. The first is using the address bar to search for a specific address or community. And then you can also click Search All Products, where you can filter down through each community throughout the United States. The address search bar brings up the firm panel information and also a map of the area that you typed into the search bar. And then from that window, you can also show all firm products and also access the NFHL viewer. If you use search all products, you can this will allow you to filter through the communities. And this is also the same landing page if you would click show all products when you're using the search address bar. Once you have selected a community, you will notice that there are several folders that list different phases of the flood hazard products. The effective products folder contains the effective firm, DFirm, and FIS. The preliminary and pending folders contains the flood hazard products when a study reaches the preliminary phase or the letter of final determination phase. The historic folder contains the older flood hazard information that is no longer effective. And then finally, the flood risk products folder contains non-regulatory flood risk information, like the raster-based water surface elevation data. In the effective products folder, the FIS is located in the FIS report folder. The firm is located in the firm panels folder, and the DFirm is located in the NFHL data state and NFHL data county folders. The source of BFE information is dependent on which floodplain zones or special flood hazard area zones that your area of interest is located in. The source of the BFE information for the detailed study zone AE with floodway, zone AH and AO, is located in the current effective FIS and on the current effective firm, and these are published by FEMA. The BFE for approximate A zones, or zone A's, is not published by FEMA, but FEMA has guidance that on using best available data, which essentially allows you to reasonably use other flood hazard data to calculate BFE information for this zone. KDA has developed statewide flood risk information by using the base level engineering projects and the regulatory floodplain mapping projects. And this BFE information can be used to calculate BFEs for Zone A floodplains in the state of Kansas. And you can do this by requesting a BFE using the BFE portal. So Zone AE with floodplains are a detailed study floodplain where the modeling includes both structures in the model and a floodway analysis. And as part of the study, cross sections were placed along the model stream and appear both on the firm and in the FIS in the data table and on the flood profile. Since BFEs are provided by FEMA, both on the firm and the FIS, you will need to use both the firm and the FIS to calculate these floodplains. The most accurate source of BFE information for a zone AE with floodplains is the floodway data table. The BFE values are to the nearest tenth of a foot, which is what floodplain development is regulated to. Unfortunately, BFE values are most accurate next to the cross sections, and they vary as you move away from the cross sections. You will need to use the flood profile in the FIS to calculate BFEs for areas that are located in between these cross sections. On the flood profile, there are many different symbols and features on it. The x-axis is the distance along the stream line and is usually in feet, but you may see miles used in older studies. On the left side of the axis is the downstream portion of a study stream, and yet as you move right along the axis, you'll continue to go further upstream. The y-axis contains the BFE values and lists the elevation unit, which is usually in feet or is in feet, and also the datum used. So the newer studies use the NAVD 88 datum, while the older studies use the NGVD 29 datum. There is a legend in the flood profile that shows important features like the flood profiles for the different recurrence intervals and the symbol used to denote the cross section. The cross section symbol is plotted along the x-axis at the stream stationing along the model stream. Here is what the flood profile looks like. The profile includes community information and stream information, along with the features mentioned in the previous slides. It should be noted that the profile also shows the location of confluences, culverts, dams, bridges, and roads that can also be used to reference areas when you're searching for your area of interest along the streamline, and also for calculating a BFE. The Zone AE with floodplain is also a detailed study floodplain, but it doesn't include the floodway analysis and the modeling. The zone can be used either for a riverine or lacustrine flooding, and the lacustrine is just another word for lakes, which can include man-made reservoirs. The BFEs for these floodplains can have a gradient or have a gradient or be static, and the sources used to calculate a BFE can be either found in using the firm or the FIS. Static elevations can be found on the firm as whole foot values in parentheses below the zone determination. Sometimes they're also found in the FIS in a table called the Summary of Stillwater Elevations. For areas that show BFEs changing very rapidly or shows a gradient, the BFEs are shown as squiggly black lines on the firm, and that is how you use to calculate a base flood elevation. Zone AHs are shallow ponding areas that have depths about 1 to 3 feet. BFEs are provided for these areas, and they can be found on the firm and in the FIS. For the static ponding areas, the BFEs can either be found on the firm as static whole foot elevations located underneath the zone determination in parentheses, or in the FIS under the Summary of Stillwater Elevations. If the Zone H floodplains have a gradient for the BFEs, these BFEs will shown under the firm as squiggly black lines, like the Zone A floodplain, Zone AE floodplains. Zone AO floodplains are sheet flows that also have a depth of about 1 to 3 feet. These floodplains use base flood depths instead of base flood values, and they appear on the firm in parentheses just under the zone determination. These floodplains are tricky to develop to, and uh, new KDA mapping projects are moving away from using these zones so that we can help communities regulate to reduce risk in their community. As stated before, FEMA doesn't provide published BFEs for Zone A floodplains. KDA, however, through their BLE mapping projects and the regulatory floodplain mapping projects, has flood risk information flood for Zone A floodplains, and we can use that to issue base flood elevations for different areas in Kansas. KDA has partnered with DASH to develop the Kansas Base Flood Elevation Portal, and this allows people in Kansas to request BFE information for any areas located in Zone A floodplains or that are unmapped. The BFE portal is free to use, but you will need to register for an account. Once you've registered, you can use the map tab to start the process to calculate to requesting a BFE. Once you use the map, zoom into your area of interest, and then you can click the area of interest tool to activate it. Once that tool is activated, move back to the map, and then you can begin drawing in your area of interest. Once you have completed the drawing, a form will populate, and this will allow you to provide information that'll be helpful for your request. Click save, and then we at KDA will then begin to process your request, and then also provide you with the BFE letter that shows the BFE value for your area of interest. So common issues to avoid when using the BFE portal is to not draw the polygon too big. This will cause us to calculate the highest BFE for the entire polygon and not necessarily to the specific area or structure on your property. Another common issue we run into is not following the outline of a building footprint. This can affect the calculation of the BFE or lag by the BFE portal, and lead to a possibility of providing the wrong value. Sometimes not providing enough detailed notes or on the purpose or construction has come up in the past. Providing information on the purpose and construction provides us with information needed to help determine which sources of data we need to calculate a BFE. Here at KDA, we have an internal policy that we are to provide the more restricted BFE value for any new construction, so that any new building would be at a lower list of flooding. And finally, a common issue we see is not providing any type of location information like address or latitude and longitude or the PLS information. The BFE portal creates a letter that you can provide with the LOMA application. And if you don't provide us with the location information, we need to do some extra research to fill in that blank information. This can lead to instances where we have the wrong address and coordinates, and this can throw off the LOMA application. Now I'm going to show you how to calculate a BFE using a flood profile in the FIS. To do this, the example community or a building we're going to look at is located at 4901 Southwest Shunga Drive in Topeka, Kansas. Here, the flooding source is Shunganugger Creek, and that's just a creek that runs through Topeka. So here to help calculate the BFE, I'm going to use our Kansas effective floodplain viewer. Here, all the tools required for calculating a BFE is available for you to use. So for our example, we have the building here, the map already located along 4901 Southwest Shunga Drive in Topeka, Kansas. And next thing we want to do is to draw a polygon that essentially is around the building footprint. Here we have a drawing tool, and this is located under the draw drop down. And here is where you can draw the polygon and then also any type of other shapes. So to draw a polygon, what we're going to do is to zoom in into our building. Here is just a community building. And next, what we're going to do is to activate the polygon tool and then navigate back over to the map and begin the drawing process. Here you want to get as close to the building footprint as possible, and if you need to, you can turn off the special flood hazard area layer in the web map to give you a clearer indication of where the building is. So after you have gotten the building footprint, next thing you want to do is double click to finish the drawing. Now with that set, we're going to draw a line that intersects the upstream portion of this building locating in the floodplain until it intersects with the flooding source streamline. So in this case is Shunganunga Creek. We have a polygon draw tool in our drawing feature, but before we do that, we must determine which is the upstream portion of the building. So here we see that our reference cross section is dB, and we see that the BFE value is 933.4 feet. If we look to our left and right cross sections, we see that to the left side is 933.4.4. And so that's a 10-foot increase. So here is our upstream portion of the floodplains, and the upstream portion of the building is this corner here. So now what we're going to do is draw a polygon that intersects this streamline for the Shunganunga Creek, or the profile baseline, using the drawing tool. But before we do that, I'm going to turn off the special flood hazard area just so I have a clearer image to draw. So with that, I'm going to zoom in so I have both the building and the streamline centered, and then click the polygon tool to begin the drawing. Here, I'm just going to draw a straight line from this northwest corner of the building that's locating in the floodplain. That's in the upstream portion, and then draw it to where it intersects the Shunganunga Creek profile baseline or streamline. Here, this may take multiple tries to get it just right, but once you figured out where this meets perpendicularly, double click to finish drawing, and now you can begin the measurement upstream of this reference cross section of dB. To begin the measurement, we want to we can use the measurement tools that's located in the current effective floodplain viewer. Here, the measurement tools are located under the measurement drop down, and here we both have area, distance, and then a location. Before we start this process, we need to determine which unit we need to measure the distance in. And here we're going to check our FIS for Shawnee County to figure out what distances the Shunganunga Creek flood profile used for stream distance. And also we're going to track down which flood profile page using this reference cross section of dB. So once we go to the flood profile, we check to see that we are in Shunganugga Creek, and then also we see our reference cross section of DB, so we have the right flood profile page. And then if we look down at the x-axis, we see that the stream distance is in feet. And so now we want to measure along the stream line from uh, reference cross section DB until our structure cross section, and make sure our units are in feet. So moving back to our current effective floodplain viewer, we can click the distance tool and then also click miles and change it to feet. So now we can begin the process. So now zooming into our streamline with both the reference cross section DB and our structure process, we can now begin the measurement along the stream center line and measuring every curve and bend in this profile. Here, our profile is relatively straight, so it should be easy to measure along the distances, but sometimes with the more meandering streams, it can be difficult. And so this is another area where you may need multiple chances to get the right distance calculation. So all you would need to do is just begin the process of where the measuring where the reference cross section DB intersects the stream profile baseline, and simply just measure along the streamline and doing your best you can to measure every change in stream. Once you're done, all you would need to do now is to double click. And now we see that our measurement is 177.0 feet upstream of cross section DB. When I was preparing for this video, my previous measurement came out to be 179.0 feet. And I'm going to use that for our continuing on in our process. But this is a case where, depending on how well you do tracing the profile baseline along the center, will determine how accurate your measurements are in feet. So once we got our measurement, now we can go back to our flood profile. And so the next step now is to measure along the stream distance on the x-axis, how far along our reference building reference cross section was upstream of our reference cross section of DB. So since we're now using this 179.0 feet, what I did here is basically take one of the comment tools for a line and drew a line that's 179 feet upstream of our reference cross section DB. And here to kind of help orient how far 179 feet is along this distances, I basically use both the distances labeled here along the x-axis. So here we see that this large dark square contains smaller squares, and there are 10 small squares into this large dark squares. And we see that the change in distance along these dark squares along the stream distance is 500 feet. So it's 59,500 feet and 59,000 feet. So we see a change of 500 feet along these along these lines along the x-axis. If we take that 500 feet and divide it by these 10 squares found in this bounding dark square, we see that each one of these lines that make up the small squares is 50 feet. So I took that 50 feet, and it takes about 3.5, I would say, of these squares to get about 179 feet. And so I took that line and drew that 179 feet above our DB cross section. So now that we have our cross section, our stationing for our structure along the streamline, now what we're going to do is now draw another reference line that is drawn vertically until it intersects with the 1% annual chance flood profile or the 100-year flood profile. And here you can check to make sure which this is by using the legend. And here the 1% annual chance flood or the 100-year flood has these two little dashes. And so here I drew a line vertically until it intersects with the 100-year flood profile at this location. And since we got that, now I drew a line over to the y-axis to get our BFE value. In this case, the BFE came out to be 933.9 feet, NAVD 88. This was calculated because if we take a look at this big dark square, we see that the change is 10 feet. So it's 940 minus 930. So that's 10. So each one of these gray squares is a 1 foot change. So here we see that we have 930. So it's 931, 932, 933, and we're just below this 934. And so that came out to be this 933.9 feet NAVD 88. If there sometimes whenever you get close to these values, sometimes it's better to err on the side of caution and round up. And so here, if this was for new construction, I probably would have round up to 934.0 feet NAVD 88, just to allow that there is some reduced risk of flooding because it's raised a tenth of a foot higher. And so that is how you calculate a BFE using the Kansas Effective Floodplain Viewer by both drawing the building footprint, drawing a line from the upstream portion of the building that's located in the floodplain that intersects diagonally or perpendicularly with the stream profile baseline, and then measure along the profile baseline from the reference cross section to your building cross section that you drew. This all can be done as shown with the Kansas Effective Floodplain Viewer, but if you have access to GIS software and you have downloaded the current effective DFIRM for your community from the MSC, once you have imported all this information into a GIS software like here is ArcGIS Pro, you can use the create feature geoprocessing tool to create a feature for the building footprint. So here I have the building footprint of this community building. Then I also have a building footprint or a feature that represents our line that is drawn from the upstream portion of the building located in the floodplain until it intersects with the stream profile baseline at a 90-degree angle. And so here's just the creating features tool. Once you're ready to measurements, ArcPro has a measurement tool. And so here you can measure a distance. And then here you can change what your units are from any type of metric. You can use feet, kilometers, whatever you're referencing. So here I'm using feet. Then all you would do is do the same thing and just measure along the stream center long, following every bend of the stream. And so that's just another way to use existing technologies or software in your office to calculate a BFE and then take that measurement and then head back to the profile to perform the measurements to get the base flood elevation. So that's the end of the training. I hope you found this helpful.